Maybe to try and help you guys understand how that whole process works, I'm just going to use water as an example, because the properties of water are really easy to understand. Refrigerant, in fact, is similar to water, and water is a refrigerant. They kind of go together. It's just something such as an R22 or an R410A is much more efficient as a refrigerant in our application. There are applications where they actually will use water as a refrigerant. So to kind of give you guys an idea of what happens in the air conditioning system, we're going to use water. On a scale, everything above 460 degrees below zero essentially is heat. Okay, so if you have a block of ice that's 460 degrees below zero, everything that we add to that block of ice above and beyond there is going to be additional heat or heat. So if you was to take a 32-degree block of ice, we're going to add X amount of BTUs and bring that 32-degree block of ice to a 32-degree water. Okay? Between point A and point B, we've done something that's called change state. Between point A and point B, we've done something which is called add latent heat. Now, so that you guys understand the difference between latent heat and what we normally call sensible heat. Sensible heat is heat that makes sense to us. Okay? Temperature change from 32 degrees to 40 degrees, that makes sense. You can read it on a scale, that's called sensible heat. Latent heat happens, and it's called the hidden heat. The hidden heat is developed in the change of state. Okay? We absorb that latent heat in the change of state. So when we go from a 32-degree block of ice to 32-degree water, there's latent heat that's added in that change of state, which is why you see the level plane on your temperature scale. So we go from 32-degree block of ice to 32-degree water. We're going to add some more sensible heat. We'll go from 32-degree water to 212-degree water. Above and beyond 212 degrees, we can get hotter than 212 degrees. We just add a little more sensible or latent heat. We'll change state, and then we do what we call superheat. That would be similar to, you know, if you guys remember your mom putting peaches or something like that in a pressure cooker. That's how she got that temperature up there, is by adding superheat. And it's because that was contained in its own atmosphere. The way you contain superheat and use it in our application is you put it all in its own atmosphere, and it becomes its own entity at that point. So superheat is a very important part of what we do with the heating and air conditioning industry. Now if we take R22 refrigerant and make it relative to the water that I was just talking about, essentially R22 refrigerant is boiling point is 41 degrees below zero. Okay, so we take R22 refrigerant, we put this in its own atmosphere, which is inside of a copper pipe. We take a compressor and we move that refrigerant inside the house and outside the house, essentially through a condensing coil and an evaporative coil. So the evaporative coil is going to absorb the heat that's in the home, right here. So if we used to take a model of our air conditioning unit, and you're going to see that it's going to blow some air off at the top there, and we're going to have our hose that comes out there with that hose uses the nano mist technology to get rid of the condensate. I'll explain condensate briefly in just a minute, but this air conditioning unit, the air that's coming out of here is essentially the air that's coming across the evaporator. So if the home was, say, like 78 degrees, and the airflow that was coming out of here was maybe it should be 58, maybe even 60 degrees coming out of the unit. Is what you've done is you've absorbed 10 degrees or maybe even 20 degrees of heat from the home. Now the way we do that is we go ahead and pump the refrigerant through the unit. It goes through a metering device. It restricts the refrigerant and drops it down to a really low pressure. Once it drops that refrigerant down to a really low pressure, it travels across the evaporator coil. Okay, now on the back side of this unit, there's going to be some air from the home traveling into the air conditioning unit. that's the air that's going to be essentially 78 degrees. As that 78-degree air goes across this evaporator coil, the transfer or the pressure drop from this point to this point allows the refrigerant to absorb a bunch of heat. Now that refrigerant is actually in a superheated form within this piping, okay? The reason it's in a superheated form is because that's how we get it to absorb the most amount of heat, and it is in vapor form. For us to get the refrigerant into a vapor form, it has to be boiled off or vaporized or turned into essentially superheat. So from this point right here to this point, you're going to change state from a semi-liquid to 100% vapor, okay? You use this point to this point to absorb additional superheat, and the superheat kind of serves another purpose. It also protects the compressor from pumping liquid refrigerant. The compressor cannot pump liquid refrigerant or it'll ruin the compressor. So that's another reason why we're real careful to make sure that we don't block the airflow or obstruct the airflow, because the coil temperature is going to drop. When the coil temperature drops, your supplier temperature is going to drop, and then you're not going to transfer enough heat, and then you're eventually going to get liquid refrigerant in the compressor. And the compressor has moving parts, pistons, oil, that kind of thing, and the liquid refrigerant will raise havoc with the compressor. So as that refrigerant travels through the compressor turns it into a hot gas, high pressure hot gas. It's absorbed even more heat from the compressor. So the refrigerant serves even another purpose. It's a coolant for the operating components of the compressor. Now as that refrigerant comes out of the compressor, it's what we call a high pressure hot gas. And it's going to go through a de-superheating phase. So you take the superheat out of it. So then we're going to go from this point to this point where we're going to change state again, latent heat like we was talking about. Change state, and then we're going to condense. So you guys have all heard the term condense. That's what this is called, the condenser. Okay, so we're rejecting heat at this point. That's where this comes into play. You're going to have hot air going outside. That hot air is going to interact with the condensate that comes off of the evaporator coil, and that's what's going to help turn that condensate into a mist. Now as that travels back through here, it goes through another process which is called subcooling. You guys don't need to know that a lot unless you get into the real technical side or the repair side of things. A couple more things that I'll just brush on without getting too in depth. Compressors. Compressors are really expensive. They're essential for the operation of the air conditioning system, and they're pretty touchy. Okay, so if you get an air conditioning unit that comes and it's been tipped on its side, it has oil in it to lubricate the moving parts. Most likely it's going to have a problem. So we need to leave the box and the air conditioner sitting upright for at least 12 hours to let the oil get back to where it should be. Airflow, all of those kinds of things. Something else that's going to probably pop up and we're going to have to deal with, even more so than the heaters, is electrical wiring and amperage and voltage. It's going to be really important that we have the proper wiring, extension cords, and those kinds of things. You want to have the air conditioning unit plugged into a dedicated outlet at all times and any time possible. In other words, we're going to not get enough power to the compressor, and it's got a lot of safety features built into it, so it should cycle itself off if it overheats, but there are those times if somebody plugs it into a long extension cord, we could have problems with compressors. One other thing that I'll just touch base on is as we absorb heat, there's another thing that we do absorb from the air, and that's called moisture or humidity. As the air passes across this evaporator coil, the evaporator coil really serves as a dehumidifier as well. So that is where your condensate is going to come from that